They told us humanoid robots were decades away, but they lied. Some of them are already working in factories, greeting guests in malls, even flying planes. And in this video, we're going country by country, uncovering the most advanced, the most shocking, and the most disturbingly human-like robots ever built. We start in China, where things have gone way beyond anything the West expected. These aren't sci-fi prototypes. They're real machines walking, flipping, lifting, and even flying planes. Unitree's got robots doing kung fu. XPeng made a robot with EV-level sensors that plays soccer. And there's one bot that just ran a half marathon like it was nothing. Seriously. Then we head over to Japan, where robots are swinging swords, working railways, and even improvising in live theater. After that, South Korea, Norway, the UK, France, Spain, Italy, Germany, and more. Each country has its own brand of humanoid madness. And yeah, some of them are straight up terrifying. But don't blink when we hit Russia and Poland, because those two are cooking up some of the most unsettling robots you've never heard of. One uses artificial muscles that move like human tissue. Another looks and talks so real, it'll leave you second guessing if it's even a machine. And at the end, we're heading back to the West, the United States. Boston Dynamics, Tesla, Figure AI, Sanctuary. Some of the most powerful humanoids out there. We're talking full-scale deployment, autonomous reasoning, factory-ready labor, and yes, a few that are already replacing humans on the job. So yeah, get ready. This is not some shiny tech demo or a YouTube prank. These humanoids are real, they're walking among us, and they're way more advanced than most people think. Some will amaze you, some will disturb you, and a few might just freak you out completely. Stay till the end, because I promise you've never seen anything like this. Okay, we all know the G1 from Unitree. The little robot that does kung fu, dances like it's on TikTok, and casually flips backwards like it's no big deal. But behind the viral clips is something way more impressive. This machine might just be the first true consumer-grade humanoid robot. Standing about 4 feet 4 inches tall, or 1.32 meters, and weighing 77 pounds, 35 kilograms, the G1 is compact, fast, and surprisingly affordable. It launched in May 2024, and Unitree wasted no time showing off what it could do, carrying 5-kilogram crates, dropping into push-ups, even dancing side by side with its quadruped cousin, the Go 2. Inside, the G1 runs on a 1.5 kilowatt-hour quick-swap battery, powering 23 high-torque joints and twin-depth cameras that help it navigate and interact in real time. Its custom-built U-Power actuators spin up to 360 RPM, giving the robot enough agility to walk at over 4.5 miles per hour, 2 meters per second, and jump a 16-inch box without a run-up. The price? Around 9,500 USD, or roughly 65,000 yuan, for the developer kit, a tenth of what similar robots in the West cost. Unitree's founder Wang Shengxing calls it the Raspberry Pi of humanoids, hoping it sparks a global wave of DIY innovation. And it's already happening. People are teaching it to play ping pong, patrol stores, and even greet guests. If Unitree nails mass production, the G1 could be the spark that lights China's humanoid robotics revolution. And while the G1 might be stealing headlines for its size to skill ratio, its taller sibling, the Unitree H1, is playing in an entirely different league. Standing at about 5 feet 11 inches, and weighing just 104 pounds, 47 kilograms, the H1 is all limbs, muscle, and insane speed. When it was revealed in August 2023, it didn't just walk onto the scene, it sprinted in and shattered the Guinness World Record for the fastest humanoid robot, clocking in at over 7.3 miles per hour, 3.3 meters per second. And just to flex, it followed that up with a standing backflip that looked almost effortless. The H1 runs on a carbon fiber frame powered by 600 Newton-meter actuators in the knees and a model predictive controller that recalculates its every step 500 times per second. In tests, engineers even shoved it with wooden beams just to show it could recover instantly. Inside the torso, you've got dual hot swappable batteries for about 4 hours of operation, and in the boosted version, a LiDAR array and NVIDIA Orin chip for real-time object detection and vision. And this isn't just a demo robot. Chinese logistics giant JD.com has already begun piloting H1 robots to load packages onto delivery bots. Rumors suggest Unitree will launch a stripped-down H1 Lite priced under $90,000, which would massively undercut anything comparable from the West. If they pull it off, don't be surprised if the next robot you see hauling boxes at the airport is jogging and wearing a Unitree badge. Now, 2025 is the year of AI agents, and DeepAgent from Abacus AI is easily one of the most powerful we've seen. They're also sponsoring today's video, which honestly makes perfect sense because this tool is genuinely next level. DeepAgent is a fully capable AI assistant that handles serious, complex tasks across research, design, productivity, and development. It can build entire websites with interactive dashboards and database support, host them for you, create deep research reports, generate sleek presentations with visuals, and connect to Gmail, Slack, Google Calendar, Jira, and more, then actually do useful things across those platforms. But what really takes it over the top is how it combines everything. It can browse the internet like a human, make bookings, get reservations, and even control apps like Figma, Canva, and Google Tasks directly on your computer using MCP integration. It takes care of entire workflows on its own. Like a tireless assistant, you don't have to micromanage. The basic chat LLM Teams plan gives you 3 DeepAgent tasks per month for just $10. The Pro tier is $20 and gives you around 25 tasks depending on complexity. Try it out at deepagent.abacus.ai and check out chatllm.abacus.ai for more. Both links are in the description. If XPeng's electric cars got you curious, iron will make you stare. Revealed in late 2024, this 5'8" 1.75 meters powerhouse tips the scales at 154 pounds, 70 kilograms, and borrows brain power straight from XPeng's autonomous driving stack. A rooftop solid-state LiDAR gives it a 720-degree wraparound view, while twin 8-megapixel cameras identical to the ones in the company's EVs feed an onboard NVIDIA Orin. Iron's 60 torque-dense joints grant 200 degrees of freedom, enough to thread a needle with one hand and hoist a 20-pound box with the other. In the debut demo, the robot dribbled a soccer ball, loaded car floor mats onto a pallet, and fist-bumped CEO He Xiaopeng, all without teleop help. XPeng says the liquid-cooled batteries are hot swappable and good for 6 hours of mixed factory duty. The price target, about $70,000, would undercut most Western rivals by half. Pilot units are already roaming XPeng's EV assembly line, scanning VIN plates and fetching torque wrenches. If scaling goes to plan, Iron may greet customers in showrooms next year and, before long, handle the late shift on China's sprawling production floors. Walker S1 is UBTECH Robotics' industrial-grade humanoid robot designed to take on real factory work, not just walk around and wave. Revealed in 2024, this biped stands about 5 feet 7 inches, 167 pounds, 76 kilograms, and is built to tackle the kind of repetitive, physically taxing jobs most humans would rather avoid. Equipped with full body articulation and advanced AI perception, Walker S1 can perform tasks like visual inspection, component assembly, screw tightening, and parcel handling, all while keeping balance and adapting to shifting factory conditions. It can carry up to 33 pounds, 15 kilograms, without compromising stability. And, thanks to its reactive gate system, it maneuvers around carts, conveyor belts, and human workers smoothly. In 2024, it was deployed at major factories including BYD, Audifal, Geely, and Foxconn, where it replaced human labor in tasks like detecting refrigerant leaks, jobs that are both hazardous and time-consuming. UBTECH claims Walker S1 could eventually handle up to 20% of factory operations, cutting human labor by half in some workflows. What makes this robot special is its BrainNet system, a shared neural architecture that lets multiple Walker S1s learn from each other in real time. If one robot figures out a faster way to tighten a screw or detect a fault, every other unit learns it too. With plans to mass produce 500 to 1,000 units by the end of 2025, Walker S1 is shaping up to be one of the most serious humanoid workforce deployments ever attempted in Asia. You've probably seen the clip, this humanoid robot sprinting across the Gobi Desert like it's training for a marathon. That's Star 1, the latest creation from Robot Era, and it's already turning heads in the robotics world. Standing about 5'6" or 1.7 meters, and weighing 143 pounds, 65 kilograms, this bot is all about movement. It's not trying to play the violin or serve drinks. It was built to run, climb, and handle rugged terrain like a mechanical athlete. Star 1 can hit speeds up to 8 miles per hour, that's 13 kilometers per hour, which is faster than most people jog. But what makes it really special is its balance system and joint coordination. It's got high torque actuators in its legs and a dynamic gate control system that adjusts in real time, so even on sand, rocks, or slopes, it stays upright and stable. The team behind Star 1 says this robot is just the beginning. The plan is to develop future models for security patrols, delivery in outdoor areas, and even emergency response in places where drones or wheels can't go. With tests already running in extreme environments, Robot Era's Star 1 could be China's next big export in humanoid tech, built for the outdoors and always ready to move. Shanghai-based Fourier Intelligence, best known for its rehab robotics, went fully humanoid with the GR1 in 2023, and its successor, the GR2, launched in 2024, is where things really start to click. Standing about 5 feet 5 inches and weighing roughly 120 pounds, 55 kilograms, the GR2 looks clean and compact. But under the shell are magnesium alloy joints that let it shoulder press up to 30 pounds per arm with surprising grace. The standout feature is something they call rehab mode. It allows the robot's arms to lock into place like parallel bars, so patients recovering from a stroke or spinal injury can lean on it while relearning to walk. There's also a mid-torso clutch system that lets therapists steer the robot manually, almost like a human Segway, guiding patients around furniture, ramps, or doorways. The early trials in hospitals across Guangzhou suggest that a single GR2 can do the work of 2 human aides during lift assist therapy. And with a projected bulk cost around $200,000, that's impressive value for a biped built to operate in clinical environments. It's not just a medical tool, it's a quiet, helpful assistant with a human presence. Unveiled in April 2024 by Shanghai-based startup AgiLab, the AgiBot A2 is a full-sized service humanoid designed for customer-facing roles in malls, showrooms, and public spaces. Standing 5 feet 6 inches, 1.69 meters tall, and weighing around 152 pounds, 69 kilograms, the A2 combines expressive design with functional mobility, aiming to serve as an interactive guide, greeter, and assistant. The robot features 40+ active degrees of freedom, including dexterous 7-DOF arms capable of lifting up to 6 kilograms per arm, and 19 DOF articulated hands for handing over delicate items like brochures or boxed products. Its vision system includes stereo depth cameras, LiDAR, and ultrasonic sensors, enabling obstacle avoidance in crowded indoor spaces. Powering the A2 is an NVIDIA Jetson Orin module that runs AgiLab's own AgiBot World software suite. The onboard voice assistant supports Mandarin and English with basic conversation handling and gesture coordination. A modular rear battery allows hot swapping in under a minute, with each pack delivering about 2 hours of active duty. AgiBot A2 was publicly demonstrated at the 2024 World AI Expo and later showcased in a pilot at the Jing'an Carry Center in Shanghai. Pricing for the developer kit starts around 15,000 USD, with leasing options available for commercial clients seeking a professional yet approachable humanoid presence in high-traffic areas. Galbot G1 turned heads at CES 2025 with a show-stealing demo. a 30-inch conveyor belt that extended straight from its chest, smoothly transferring boxes onto a nearby shelf. At 5 feet 8 inches and 143 pounds, 65 kilograms, the G1 might not be flashy in design, but it's packed with clever engineering. Each arm is powered by brushless drone motors and can carry up to 33 pounds, making it ideal for logistics and warehouse tasks. There's no fragile LCD on its face. Instead, expressive emoji eyes are laser projected onto a matte black visor, giving it personality without sacrificing durability. The G1 also speaks fluently in Mandarin and Cantonese through a cloud-based Tencent NLP system, allowing it to handle basic worker interactions, explain barcode errors, or even notify managers when items are missing. One viral clip shows it calmly explaining a misread parcel ID to a human supervisor before gently placing the box on a different sorting lane. 10 G1 prototypes have already logged over 1,000 hours in JD Logistics' Cold Stigil warehouse, handling freezing temps and 12-hour shifts with zero mechanical failures. If reliability is the name of the game, Galbot may have just built the MVP of robot labor. Pudu Robotics, known worldwide for their restaurant delivery bots, took a bold step into the humanoid race with the D9, revealed in December 2024. This sleek, full-size biped stands about 5 feet 7 inches and weighs roughly 143 pounds, 65 kilograms. And it's not just for show. This thing means business, with 42 degrees of freedom and peak joint torque hitting 352 Newton meters. The D9 moves like a worker, not a performer. In live warehouse demos, it walks steadily at 4.5 miles per hour, 2 meters per second, climbs 10-degree ramps without slowing, and carries 20 kilograms of payload on a compact shelf mounted to its back. It's built to go wherever packages need moving and do it all day. Pudu set early unit pricing between $20,000 and $30,000 with a clear mission: beat out human cart pushers and pallet jacks on cost per hour. The company even gave it a fitting tagline: born to serve. And if the production scale plays out like they plan, the D9 might become a common sight in warehouses, big box stores, and logistics centers by 2026. Quietly replacing one of retail's most repetitive jobs. In 2024, researchers at KAIST, the Korea Advanced Institute of Science and Technology, unveiled PIBOT, a humanoid robot built to fly real airplanes by physically operating cockpit controls. Unlike traditional autopilots or flight software, PIBOT interacts with the same switches, buttons, and yokes a human pilot would, requiring no cockpit modifications. The robot stands about 5 feet 2 inches, 1.58 meters tall, and is equipped with multiple degrees of freedom in each arm, allowing it to perform complex pilot movements like adjusting the throttle, manipulating the control stick, and toggling switches on overhead panels. Its stereo vision cameras are used to read analog instruments and flight displays, and it can interpret external conditions such as warning lights and runway signs. PIBOT's most advanced capability is its integration with large language models, LLMs, which allow it to understand and reference aviation manuals in real time, react to emergencies, and make decisions based on written procedures, similar to a trained human pilot. In simulator tests, PIBOT successfully completed full gate-to-gate flight sequences, including takeoff and landing. The research team at KAIST is developing PIBOT as a backup or emergency pilot for future unmanned or single-pilot aircraft. With further development, it could become the world's first humanoid certified to co-pilot real planes. When the AstriBot S1 yanked a tablecloth from under a full setting of glassware and didn't break a thing, people took notice. Unveiled in April 2024 by Shenzhen-based startup AstriBot, a subsidiary of Stardust Intelligence, the S1 is a humanoid robot engineered for high speed, high precision tasks in domestic and service environments. Standing approximately 1.70 meters tall and weighing around 80 kilograms, the S1 features 7 degrees of freedom per arm, enabling a range of complex movements. The robot's actuators allow for arm movements at speeds up to 10 meters per second, with a payload capacity of 5 kilograms per arm. Demonstrations have showcased the S1 performing tasks such as pulling a tablecloth from beneath a set of wine glasses without disturbing them, pouring beverages, slicing vegetables, and writing calligraphy. Powered by advanced AI and imitation learning algorithms, the S1 can autonomously execute a variety of household chores, including ironing clothes, folding laundry, and preparing simple meals. Its battery supports continuous operation for 4 to 6 hours, with the option for plug-in charging during use. While the S1 currently lacks legged locomotion, utilizing a stationary or wheeled base instead, its upper body dexterity positions it as a versatile assistant for tasks requiring precision and speed. AstriBot aims to make the S1 commercially available, targeting applications in homes, hospitality, and retail settings. Now, AI robots are getting smarter by the day, obviously, and let's be real, they will take a lot of jobs. That's not a warning, it's just reality. The work world is splitting fast into two camps, those who work with AI and those who get left behind. While many are still panicking, smart professionals are already adapting. Because the truth is, AI doesn't replace people, it replaces people who don't know how to use it. That's exactly why Outskill built the AI Generalist Fellowship. They're also sponsoring today's video, and honestly, this program is worth your attention. It's a 6-month intensive program that's designed to turn you into the kind of professional every company is now scrambling to hire. You'll go through 6 levels, learning prompt engineering, mastering tools like Claude, ChatGPT, Cursor, Runway, Replit, and more. You'll build your own AI agents, create full apps without writing code, and even make AI clones of yourself. Emily, a member of the current cohort, landed a $1,500 consulting gig just 3 weeks in. The full price is $9,995, but my audience gets a 50% scholarship. This program isn't open to everyone, it's built exclusively for people who are serious, which is why you'll need to go through an interview to get in, apply through the link below because you might not get a chance to apply again. On April 19th, 2025, during the Yizhuang Half Marathon in Beijing, the humanoid robot Tiangong Ultra, developed by the Beijing Humanoid Robot Innovation Center, completed the 21.0975-kilometer race in 2 hours, 40 minutes, and 42 seconds, marking a significant achievement in robotics. Standing approximately 1.80 meters tall and weighing around 55 kilograms, Tiangong Ultra features long legs and an advanced control system that emulates human running mechanics. Its performance was supported by an algorithm designed to replicate human marathon running, allowing it to maintain a consistent pace throughout the race. The robot required 3 battery swaps during the event, each incurring a 10-minute penalty as per the race rules. Despite these challenges, Tiangong Ultra outperformed other robotic participants, with only 6 out of the 21 robots completing the course. While the robot's time was significantly slower than the human winner's 1 hour and 2 minutes, the event highlighted the potential of humanoid robots in dynamic, real-world environments. However, it's important to note that Tiangong Ultra, like its counterparts, required human supervision and assistance during the race, indicating that fully autonomous operation in complex tasks remains a goal for future development. The Beijing Humanoid Robot Innovation Center plans to leverage insights from this event to enhance the capabilities of humanoid robots for practical applications in industries such as logistics, manufacturing, and public services. Unveiled at the 2024 World Robotics Expo in Beijing, the EngineAI SE01 is one of China's first humanoids built specifically for industrial research and factory trials. No dance routines, just practical motion. The aluminum-framed biped stands a little over 5.5 feet tall, 1.65 meters, and weighs about 60 kilograms, giving it a sturdy but maneuverable footprint for crowded production lines. Instead of hand-coding every joint trajectory, EngineAI trains the robot's gate controller on thousands of human motion capture clips, then refines balance with a high-frequency model predictive loop. The result is a stride that looks surprisingly natural. In public demos, the SE01 walked narrow planks, sidestepped obstacles, and recovered from deliberate shoves without tipping over. Its architecture exposes 32 torque-controlled joints through ROS2, so labs can plug in their own planners or reinforcement learning policies. EngineAI is positioning the platform as an industrial intern. Early tests show it threading bolts, operating cordless drivers, and placing components on assembly fixtures, tasks that demand both dexterity and repeatability. A stripped-down developer kit, legs, torso, head, and open software stack lists for around $10,000, making SE01 one of the most affordable, full-size humanoid research rigs on the market. It isn't yet loading pallets at Foxconn, but with universities and automation integrators already ordering kits, SE01 could become the go-to sandbox for anyone who wants to teach a humanoid real factory skills without starting from scratch. The Booster T1 might not be the tallest humanoid out there, but it's quickly becoming one of the most versatile platforms for developers and researchers. It's a compact, open-source humanoid robot that's making waves in the robotics community. Developed by Beijing-based Booster Robotics, the T1 stands at about 4 feet, 1.2 meters tall, and weighs around 66 pounds, 30 kilograms, making it both portable and sturdy. It's designed specifically for researchers, students, and developers looking for a hands-on robotics platform. The T1 features 23 degrees of freedom, allowing for smooth, human-like movements. Its advanced motion control system lets it walk, play soccer, and even perform kung fu moves with impressive precision. Built with high-strength materials, the T1 can handle falls and collisions, making it ideal for dynamic testing environments. Inside, it runs on a 14-core Intel i7 processor paired with an NVIDIA AGX Orin GPU, delivering up to 200 trillion operations per second, TOPS, of AI computing power. It's outfitted with a depth camera, 9-axis IMU, microphone array, and speaker, giving it strong sensory and interaction capabilities. It supports ROS2, Python, and C++, and works seamlessly with simulation platforms like IsaacSim, Mujoko, and WebOts. With its mix of flexibility, power, and open-source accessibility, the Booster T1 is shaping up to be a go-to humanoid for education, research, and early product development across a wide range of industries. The Kepler Forerunner K2 is a humanoid robot developed by Shanghai-based Kepler Robotics, designed for industrial and commercial applications. Standing at approximately 5 feet 10 inches, 178 centimeters, and weighing around 187 pounds, 85 kilograms, the K2 features 52 degrees of freedom, enabling a wide range of movements and tasks. Each of its dexterous hands supports 11 degrees of freedom and can carry up to 33 pounds, 15 kilograms, thanks to advanced actuators and tactile sensors. The robot is powered by a 2.33 KHI battery, allowing for up to 8 hours of continuous operation. The K2 integrates a cloud-based cognitive model with an embodied control system, utilizing both imitation and reinforcement learning for skill acquisition. Its advanced perception systems, including visual recognition and SLAM, enable it to navigate complex environments and interact effectively with humans. Currently undergoing real-world testing in automotive manufacturing settings, the K2 is performing tasks such as quality inspections and assembly operations. Kepler Robotics aims to commence mass production of the Forerunner K2 by the end of 2024, positioning it as a versatile solution for various industries, including manufacturing, logistics, and research. Sophia isn't just a robot, she's a global icon in the world of artificial intelligence. Developed by Hong Kong-based Hanson Robotics, Sophia was activated on February 14, 2016, and made her first public appearance at South by Southwest SSSW in Austin, Texas, in March 2016. Designed to resemble Audrey Hepburn, her face is crafted from a patented material called frubber, flesh rubber, which allows her to exhibit over 60 human-like facial expressions. Sophia's AI capabilities enable her to process visual data, recognize faces, and engage in natural language conversations. She can track and recognize faces, maintain eye contact, and understand speech, making interactions with her feel remarkably human-like. Her software combines machine learning, natural language processing, and speech recognition, allowing her to improve over time through interactions. In October 2017, Sophia made history by becoming the first robot to receive citizenship from Saudi Arabia, a move that sparked global discussions about the rights and roles of robots in society. She has since addressed the United Nations, engaged in interviews with media personalities like Jimmy Fallon and Will Smith, and participated in various conferences worldwide. Beyond her media appearances, Sophia serves as a platform for AI and robotics research, exploring applications in education, healthcare, and customer service. Hanson Robotics envisions Sophia as a step towards empathetic machines that can assist in therapy, companionship, and social interaction. Sophia's presence continues to challenge our perceptions of AI and robotics, prompting discussions about the future of human-robot relationships and the ethical considerations they entail. But real quick, if you've been following all this AI news and thinking, okay, this is cool, but what can I actually do with it? You're definitely not alone. That's why we created the AI Income Blueprint. It shows you 7 ways regular people are using AI to build extra income streams on the side. No tech skills needed, and you can automate everything pretty easily. The guide contains simple, proven methods using tools I often talk about on this channel. Download it free by clicking the link in the description. Japan's legendary swordmaster Musashi might not have imagined this, but the University of Tokyo did. Meet QubiXMusashi, unveiled in mid-2024. A high-performance humanoid created not for combat, but for precision dexterity and full-body coordination, standing 5 feet 7 inches, 1.70 meters, and weighing just over 130 pounds, 59 kilograms. This robot was designed to master motion tasks like sword swinging, archery, and tool handling, all through human-style mechanics. What makes Musashi special isn't just how it moves, it's how it learns. It uses a multi-layered feedback system combining visual motion capture, muscle-level torque sensing, and reinforcement learning to gradually refine each gesture. In one demo, it handled a boken wooden sword with such control and balance that martial artists in the room applauded. The robot's modular limbs can be swapped for task-specific tools, and its dynamic balance system lets it recover gracefully from nudges or shifts in terrain. Though still a research platform, the long-term goal is to apply QubiXMusashi's movement engine to surgical robotics, disaster response, and even sports training. It's not here to fight, but to show the world how deeply Japan understands movement as both science and art. And JR West, one of Japan's largest railway operators, teamed up with robotics developers in 2024. They didn't build a robot for the lab, they built one for hard, dirty infrastructure work. Their full-size rail maintenance humanoid stands 6 feet 1 inch, 1.85 meters tall, weighs over 200 pounds, 91 kilograms, and was specifically created to handle inspection, wiring, and repair tasks on active railway lines. The robot is mounted on a hydraulic boom lift, but once in place, it moves like a human. Twin 7 DOF arms powered by force-controlled actuators can handle wrenches, test meters, and specialized tools, while its head is equipped with 360-degree stereo vision and thermal imaging. The hands are fine-tuned enough to unbolt rusty fasteners or plug diagnostic cables without breaking anything. And what makes this robot especially impressive is its telepresence interface. Workers in a safe control center wear a motion tracking harness that mirrors their exact posture and hand movements onto the robot in real time with sub-100 millisecond latency. In field tests, the robot successfully rewired signal boxes 30 feet off the ground, no scaffolding needed. It's not a PR stunt, it's a serious attempt to put humanoid robots to work where safety and precision are life-critical. Hospitals in Tokyo are quietly testing a robot that could redefine elder care. And her name is AREC, AI-driven robot for embrace and care. Developed by Waseda University and unveiled in early 2025, AREC is a full-bodied nurse assistant humanoid built to support aging populations with basic physical aid, companionship, and emotional intelligence. Weighing approximately 150 kilograms, 330 pounds. AREC is designed to assist with tasks such as repositioning patients to prevent bed sores, helping with dressing, and even preparing simple meals. Equipped with advanced sensors and actuators, AREC can perform delicate tasks like helping patients sit up, put on socks, cook scrambled eggs, and fold laundry. Its development is part of a broader initiative to integrate robotics into elder care, aiming to alleviate the burden on human caregivers. While still in the prototype stage, ERIC is expected to be ready for deployment in nursing care and medical facilities by around 2030, with an initial cost estimated at no less than 10 million yen, approximately $67,000. Experts believe that integrating robots like ERIC into elder care can enhance the quality of care and address workforce shortages. Alter 3 is the latest iteration in the Alter series of humanoid robots developed by Osaka University in collaboration with Mixi Corporation. Unveiled in 2020, Alter 3 is powered by an artificial neural network and is designed to explore the intersection of robotics and the arts. Notably, it has conducted orchestras at the New National Theatre in Tokyo and participated in various live performances, demonstrating its musical capabilities. The robot features a combination of prosthetic skin on its face, neck, and arms up to the elbows, with other parts exposing its mechanical structure. This design choice highlights the blend of humanity and machinery, prompting discussions about the nature of life and artificial intelligence. Alter 3 utilizes 42 actuators controlled by a central pattern generator integrated with a neural network, allowing for fluid and lifelike movements. Equipped with optical and distance sensors as well as microphones, Alter 3 can respond dynamically to its environment. Its development aims to probe fundamental questions about consciousness and the potential for robots to possess a sense of self. Experiments involving mirror self-recognition and the rubber hand illusion have been conducted to assess Alter 3's capacity for self-awareness. South Korea's Rainbow Robotics, known for its bipedal R&D roots at KAIST, launched its first commercial humanoid in 2024, the RBY1. Standing about 5 feet 8 inches, 1.73 meters, and weighing 130 pounds, 59 kilograms, this robot blends Korea's academic precision with a real push toward industrial utility. RBY1's structure leans into practicality. Aluminum and carbon fiber joints, built-in torque sensors, and an open control architecture for lab and field deployment. It walks like a human, carries light loads, and is trained to handle real-world interactions in logistics, inspection, and customer engagement. A custom real-time OS and joint control system allows researchers and developers to fully reprogram its behavior without third-party dependence. It's also designed to sync with Rainbow's quadrupeds and robotic arms, turning it into a modular part of a much larger robotic ecosystem. That's not just theory either. Demo units have been spotted working alongside automation lines at Incheon-based factories. With prices aimed under $100,000, RBY1 could position Rainbow Robotics as Korea's best hope in the global humanoid race. And with Hyundai investing heavily in domestic robotics, RBY1 might soon be greeting customers, or moving parts, in Seoul malls and smart factories. Norway-based 1X Technologies, backed by OpenAI and known for its work on androids like Eve, unveiled the Neo Gamma model in 2025, a humanoid that finally steps away from the lab and into the workplace. Standing 6 feet tall, 1.83 meters, and weighing around 175 pounds, 80 kilograms, Neo Gamma isn't designed to dance or do backflips. Its goal is more grounded: handle everyday physical labor where robots still struggle. Folding clothes, sorting boxes, holding tools, or loading shelves. The hands are fitted with multimodal tactile sensors offering fine-grained grip control, while vision is powered by OpenAI's latest embedded visual language models running locally. The robot uses servo-efficient walking rather than high-speed agility, allowing it to balance energy use across long hours of operation. A central pelvis-mounted battery powers 8 hours of runtime, with modular hot swaps designed for continuous shifts. Neo Gamma was first tested in a logistics warehouse outside Oslo, where it autonomously assisted in loading and shelf-stocking tasks while adapting to workers around it. With manufacturing plans in Europe and North America and a focus on workforce augmentation over flashy tricks, Neo Gamma might quietly become one of the most widely deployed humanoids in the West, without anyone realizing it was Norwegian. The UK's Mk stunned the world when it was first introduced in late 2021, but the version showcased through 2023 and 2024 pushed things to a whole new level, so much so that many have started calling it Gen 2, even though Engineered Arts never officially used that label. Standing 5 feet 8 inches, 1.73 meters tall, Mk still runs on the company's signature Mesmer platform, now enhanced with additional facial actuators, smoother joint articulation, and significantly improved conversational timing. The biggest shift? Hyper-responsive facial feedback. This latest version can blink, squint, smile, and subtly change its posture in sync with your voice as if it's reacting not just to your words, but your tone and pauses. It feels like talking to something that listens. Beneath that lifelike behavior is an open AI interface. Engineered Arts doesn't program its own intelligence, so you can connect anything from GPT-based models to your own reinforcement learning stack. The underlying chassis has evolved too. It's now more modular, lighter in construction, and equipped with upgraded servos that allow for more fluid body movement and finer hand gestures. While full walking is still limited to short, controlled steps, the robot can now move in place, gesture with precision, and shift its weight naturally, all while maintaining eye contact. Mk wasn't built to lift crates or weld parts. It was designed for presence. As a greeter, assistant, or demonstration unit, it's unmatched in emotional realism. And let's be honest, once you've had a face-to-face conversation with it, you don't forget it. Not because it feels like a machine, but because it almost doesn't. The UK is stepping into the humanoid robot game with a serious contender, Meet HMND-01. It's the debut robot from London-based startup Humanoid, founded in 2024 by Artem Sokolov. And this machine isn't here to do party tricks. It's built from the ground up for real, everyday work. At 5'9", 1.75 meters, and about 154 pounds, HMND-01 looks clean and practical with a design focused more on function than flair. What makes it stand out is its balance of power and precision. It walks at 1.5 meters per second, fast enough to keep up on a factory floor, and can lift up to 15 kilograms without a problem. Its joints are built for repeatable tasks, meaning you can count on it to perform with consistency. Everything's modular too, so if one part breaks or needs upgrading, you don't have to take apart the whole robot. The real goal? Fill in the gaps where companies struggle to hire for repetitive, physical tasks. From logistics and warehouse work to handling light tools and production lines, HMND-01 is designed to blend into existing workflows, not force a redesign. It's early days, but if scaling goes well, the UK might have just launched its first true work-ready humanoid. G2, released in 2024 by French startup PAL Robotics, is a modular, open-source humanoid designed to be hacked, customized, and rebuilt by anyone, from labs to indie devs. It stands at 5 feet 3 inches, 1.75 pounds, 34 kilograms, with a lightweight frame, expressive head, and robotic arms that are faster, smoother, and more dexterous than its predecessor. The biggest update, full bipedal walking support. G2 can now balance, pivot, and move in constrained spaces, making it not just a desktop companion, but a full-scale mobile research platform. The system runs on ROS2, Robot Operating System, and both hardware schematics and code are completely open source, allowing developers to add features, train new behaviors, and plug in LLMs or vision models. It's already popular in education, with universities in France and Canada using it to teach AI and robotics with a real-world platform that students can take apart and reprogram. G2 isn't built for factories or retail. It's made for learning, tinkering, and testing the boundaries of human-robot interaction. And for open source enthusiasts, it's about as close to a DIY humanoid as the real world gets. Spain's PAL Robotics dropped the second generation Talos in 2024, and this time it's not just a research platform, it's a serious industrial biped. Standing 6 feet 1 inch, 1.85 meters tall, and weighing about 220 pounds, 100 kilograms, Talos 2 is built like an athlete in a lab coat. It's designed for tasks that require strength, precision, and safety all at once. The robot features fully torque-controlled joints, allowing fine-grained force feedback and real-time reaction to unexpected resistance. That makes it ideal for environments like aerospace manufacturing, where bumping into a plane wing or over-tightening a bolt is a very expensive mistake. Talos 2 supports both ROS2 and custom industrial integration, and PAL equipped it with vision, haptics, and voice so it can be deployed in collaborative roles. During a live demo in Barcelona, the robot helped a human technician mount parts to a vertical surface using synchronized timing and verbal cues. Talos 2 isn't cheap, and it's not for everyone. But if your company builds planes, satellites, or anything where human-level dexterity matters, this robot doesn't just lift its weight, it earns its keep. Also from PAL Robotics, the compact and friendly ARI2 was launched in 2024 as a next-gen social humanoid designed to live in public spaces, not factories. Standing 5 feet 5 inches, 1.65 meters, and rolling on a discrete mobile base, ARI2 sports a realistic humanoid torso, animated LED eyes, and fully articulated arms for gesture-based interaction. The focus here is human-centered design. ARI2's voice assistant supports multiple languages, and its AI stack recognizes faces, emotional tone, and basic gestures. It can wave, nod, point, and even mimic empathy using timed facial animations. At the 2024 Smart City Expo in Barcelona, ARI2 was deployed as a public assistant that helped visitors navigate the venue, answered questions in English, Spanish, and Catalan, and even posed for selfies. It integrates with municipal databases, building systems, and tourism APIs, making it the kind of robot cities can actually use. It's not built to climb stairs or carry heavy boxes, but in places like airports, libraries, or events, ARI2 can act as an assistant, greeter, and guide with a personality that actually makes people want to talk to it. Italy's most famous humanoid research platform got a major upgrade in 2024 with the release of iCub3 Telepresence. Designed by the Italian Institute of Technology, this version pushes the iCub series into new territory, embodied remote control. Standing around 3 feet 11 inches, 1.2 meters, iCub3 isn't large, but what it lacks in height, it makes up for in control. Through a custom exosuit and VR rig, a remote operator can see through the robot's eyes, move its limbs, and even feel tactile sensations via haptic feedback. In live demos, researchers in Italy used iCub3 to interact with a room in Japan, picking up a coffee cup, waving, and responding to questions from across the world. It's part of a growing trend toward telepresence robotics, where robots become physical avatars in places humans can't or don't want to be. And the robot is equipped with 53 degrees of freedom, high-res stereo vision, and expressive face modules. While not built for heavy industry, iQ3 is an ideal testbed for remote care, education, and research, and one of the few bots that lets humans inhabit a robot body in real time. Germany's Neuro Robotics is bringing serious engineering firepower to the humanoid race with their latest evolution, Forerunner Gen 3. Set for release in June 2025, this third-generation model is bigger, smarter, and way more adaptable than its earlier versions. Standing at nearly 6 feet tall, 1.8 meters, and weighing around 176 pounds, 80 kilograms, Forerunner is built for actual utility, not just lab tests or flashy tech expo. What makes Forerunner stand out is its modular design. Its forearms and tooling can be swapped out for different tasks, whether it's handling hospital logistics, assisting with warehouse packing, or even supporting elderly care routines. The robot comes equipped with an advanced 3D vision system for depth perception, object recognition, and even gesture interpretation, making it feel intuitive in tight human environment. Cognitive features include real-time spatial awareness, multi-sensor fusion, and AI-powered decision-making that adjusts its behavior based on the context, so it doesn't just move, it thinks. Remote operation is also built in, allowing humans to guide it or override commands when needed. Neura Robotics isn't trying to make a viral robot, they're trying to make a useful one. And with the Gen 3 launch, Fourier 1 could quietly become one of Europe's most capable humanoids, ready for homes, hospitals, and industry alike. The Toro, unveiled in 2024 by Germany's DLR, Deutsches Zentrum für Luftraumfahrt, is all about controlled power and robotic balance. At just over 6 feet, 1.85 meters tall, and weighing about 220 pounds, 100 kilograms, Toro is designed to operate in high-risk environments, like space stations, research labs, or nuclear facilities, where sending a human is risky or just plain impossible. Its upgraded actuation system allows real-time reaction to force, while its whole-body control algorithms let it make complex, coordinated movements with a single, high-level command. One of its biggest strengths? Fall recovery. In tests, Toro was pushed hard from multiple directions, lost balance, and executed human-like correction strategies to stay upright. The robot's sensor suite includes force-torque sensors, stereo cameras, LiDAR, and IMUs, giving it an awareness of its surroundings that goes far beyond most research bots. Toro is a research robot first, but a very advanced one. DLR envisions it as a tool for long-duration missions in environments like Mars, the Moon, or radiation zones. And honestly, it's one of the few humanoids that looks ready to take orders in zero gravity. Germany's Karlsruhe Institute of Technology, KIT, rolled out ARMR7 in 2024, and it's already being described as one of the smartest humanoid assistants designed for real-world human-robot collaboration. At 5 feet 9 inches, 1.75 meters, and about 150 pounds, 68 kilograms, ARMR7 isn't built for brute strength. Its AI stack integrates semantic memory, so it can remember previous interactions, objects, and routines. During a demo in Karlsruhe, it worked side by side with an elderly man in a kitchen, remembered where the sugar jar was placed the day before, and offered to hand it over when it noticed the user starting tea prep. Its dual-arm system supports fine manipulation, including unwrapping packaging, opening jars, and even loading dishwashers. Vision and force combat help it interact delicately with people and objects alike. ARMR7 isn't flashy, but it's deeply intelligent in a quiet way. It's the kind of robot that doesn't just take voice commands, it adapts to your habits, your space, and your needs. In a world filled with humanoids doing flips and backflips, ARMR7 just wants to help you clean up after dinner, and that might be the bigger breakthrough. Clone Alpha, unveiled in early 2025 by Clone Robotics, is easily one of the most radical entries in the humanoid race, because it's not just copying how humans move, it's copying what we're made of. This Poland-based startup stunned the robotics world by ditching traditional motors and instead powering its humanoid with tendon-driven artificial muscles modeled after the way real human tissue works. These muscle units contract, relax, and flex with variable tension, enabling movement that's eerily smooth, sometimes indistinguishable from an actual person. Clone Alpha stands around 5 feet 10 inches and weighs about 154 pounds, 70 kilograms. It's not just the limbs that are biologically inspired. Everything from joint placement to grip behavior has been mapped from human biomechanics. Each finger, for example, is driven by bundled tendons and pressure sensors, capable of reacting to micro-resistance in real time. In early demos, Alpha performed tasks like lifting weights with visible muscle tension, holding raw eggs, typing on a keyboard, and even demonstrating expressive hand gestures. And the goal? A full-body robotic system that behaves like a human, without relying on noisy servos or rigid mechanisms. Clone Robotics is now offering modular Alpha arms and hands as standalone units for research and prosthetics, while the full-body model is expected to enter pilot trials by the end of 2025. If successful, Clone Alpha could mark the start of biomechanically realistic robots that finally close the gap between machine and man. Canada's Sanctuary AI grabbed the world's attention with Phoenix Gen 7, introduced in mid-2024 as a full-sized humanoid built for one goal: do actual work. Standing 5 feet 7 inches, 1.70 meters tall, and weighing around 154 pounds, 70 kilograms, but inside it's all business. Sanctuary didn't just throw LLMs at a robot body, they built a cognitive architecture, a software system designed to mimic perception, memory, reasoning, and action. Phoenix can read a room, understand what you said, plan a task, and then carry it out with human-like decision-making. Gen 7 is equipped with hands that rival human dexterity, including 20 degrees of freedom, multi-axis torque sensing, and fine grip control. In test demos, it folded towels, picked up fragile objects, and operated warehouse tools, all autonomously. It can walk, turn, and recover from small bumps, though it's primarily designed for static location jobs like sorting, packaging, and tooling assistant. Sanctuary is positioning it as a robot that can actually replace human labor without retraining the world around it. Gen 7 isn't just a lab project, it's the first real attempt at a humanoid worker for the modern economy. Just 1 year after Gen 7, Phoenix Gen 8 landed in 2025 with massive upgrades under the hood. Still the same height, 5 feet 7 inches, and roughly 155 pounds, 70 kilograms, but almost everything inside is smarter, faster, and more intuitive. The headline? Full multimodal reasoning. Gen 8 doesn't just respond to prompts, it combines visual data, sensor feedback, memory, and goal tracking in real time. It can glance at a cluttered workbench, identify the task, find the tool, and adjust mid-action if something shifts or breaks. Sanctuary has trained this version using its proprietary AI worker training simulation suite, which exposes Phoenix to thousands of job scenarios, from retail stocking to lab equipment setup. And it's not just simulations anymore. Early field trials are underway with real companies in logistics and materials testing. Its hands now support power tool usage, and its movement system has been refined to feel even more natural in confined or unpredictable spaces. The battery system got an upgrade too, allowing up to 5 hours of continuous operation. Phoenix Gen 8 may not have a face that smiles or entertains, but that's the point. It's not for amusement. This is a machine built to clock in, do the job, and ask what's next. Iran's Shurena series has been under development for over a decade, but in 2024, the Shurena model showed just how far the project had come. Developed by the University of Tehran, this humanoid is 6 feet tall, 1.83 meters, and weighs about 137 pounds, 62 kilograms, with a full-body structure designed for research, demonstration, and national tech prestige. Shurena V can walk, turn, balance on uneven terrain, and even climb shallow steps. But where it shines is in its hand and finger dexterity, thanks to a completely redesigned arm system with tactile sensors and torque control. Shurena can perform basic object manipulation tasks like picking up bottles, operating tools, or pressing buttons on a panel. It also supports Farsi voice interaction, gesture recognition, and has face tracking through dual stereo cameras. Though it's not as fast or autonomous as Western rivals, Shurena V is seen as a major leap forward for Iran's domestic robotics scene, especially since it's entirely developed and assembled locally. The project's real value lies in training engineers and pushing tech independence. While it may not show up in a commercial warehouse soon, Shurena V represents Iran's most advanced step yet toward full humanoid autonomy. India made a bold new statement in humanoid robotics with the unveiling of Skanda in 2024, developed by Gujarat-based Kodi Technolab. Revealed during the vibrant Gujarat summit and even introduced to Prime Minister Narendra Modi, Skanda isn't just a robot, it's a symbol of India's tech ambitions stepping into the global humanoid race. Standing approximately 5 feet 7 inches, 1.70 meters tall, Skanda features a humanoid torso with a sleek head, animated facial projections, and fully functional arms. While it doesn't walk on legs, it moves on a stable, wheeled base. Skanda is built for high-quality interaction, not heavy lifting. The system runs on an advanced AI stack that includes speech recognition, emotion analysis, and contextual response generation, allowing it to hold real conversations with users in English, Hindi, and regional languages. Its current focus is on customer engagement and brand representation. You'll find it giving guided tours, answering queries at tech expos, or assisting guests at corporate events. It's not as mechanically complex as some global rivals, but in terms of software intelligence and human-centric design, Skanda represents a big step forward for India's domestic robotics ecosystem. And unlike many prototypes, Skanda is already in the field, talking, interacting, and turning heads in public. Vyommitra 3, launched in 2024 by India's Invento Robotics, is all about presence and interaction. Unlike robots built to lift boxes or assemble gadgets, Vyommtra's job is to connect with people, whether in a hospital, hotel, bank, or airport. Standing just under 5 feet 7 inches and weighing about 120 pounds, 55 kilograms, Vyommitra 3 rides on a smart wheeled base and features a humanoid torso with gesture-capable arms, a touchscreen chest, and a face designed for expressive interaction. The latest version includes improved voice recognition in multiple Indian languages, facial emotion analysis, and a tighter integration with back-end systems like hospital records or retail inventory. In healthcare pilots, Vyommitra has helped direct patients, check appointment schedules, and even offer basic wellness tips. It's also being deployed in temples and banks, where it answers routine questions and helps visitors navigate services. Vyommitra doesn't try to be hyper-realistic, it's clearly a robot. But that's part of its charm. People approach it without fear or hesitation. In a world chasing hyperhuman robots, Vyommitra 3 stands out for making AI feel helpful, warm, and approachable, without trying to pretend it's one of us. India's Vyommitra MTR, developed by the Indian Space Research Organization ISRO, isn't designed for Earth, it's headed to space. Revealed in 2024 as the upgraded version of the original prototype, this humanoid robot is built to fly aboard India's Gaganyaan crewed space missions. As a robotic crew member, Vyommitra is roughly 5 feet 5 inches tall, 1.65 meters, and is designed to work in microgravity environments, operating control panels, reading displays, flipping switches, and communicating with mission control. Unlike most humanoids, it doesn't walk, it's tethered, or floats, but its arms, neck, and fingers are highly articulated, built for precision in tight zero-G conditions. It can monitor cabin environment variables like CO2 and temperature, and also speak in Hindi and English. Vyommitra is not just a sensor platform, it's a communicative assistant that can respond to voice, execute scripted sequences, and provide feedback to ground teams. ISRO plans to fly Vyommitra on an uncrewed Gaganyaan test mission, helping simulate crewed conditions. It's a uniquely Indian approach to space robotics, not trying to mimic humans, but adapting humanoid form to fit the harshest environment imaginable. Russia's RoboC2, released by Promobot LLC in 2024, is more android than robot, built to look, sound, and even breathe like a human. This head and torso humanoid is focused on hyper-realistic, face-to-face interaction, and it's already being deployed in banks, government offices, airports, and museums. At first glance, RoboC2's skin texture, blinking, and lip syncing seem more like a movie prop than an AI interface, but under the surface, it houses a full conversational AI stack, facial recognition, and integration with back-end systems like ID verification, queue management, or visitor logs. It can remember past users, greet them by name, answer questions, and update information in real time. The voice system is multilingual, and the face can be customized to resemble real individuals, including historical figures, celebrities, or corporate mascots. Promobot even offers a digital twin service where the robot mimics your voice and expressions based on video training data. Robo C2 isn't built to walk or lift things. It's built to hold eye contact and build trust. And in places where human staff can't always be present, that can be more valuable than you'd expect. Saudi Arabia stepped into the humanoid race in 2024 with the unveiling of Sara, the country's first interactive humanoid robot developed by QSS Robotics in partnership with the Saudi Data and AI Authority. Sara isn't just a research prototype or showroom mascot. She's designed to represent a new wave of culturally grounded, socially intelligent robots. Standing around 5 feet 6 inches, 1.67 meters tall, and built with a smooth human-like exterior, Sara speaks fluent Arabic and English, responds to voice commands, and uses facial recognition to maintain eye contact and personalize interactions. Her core purpose? Human engagement. From greeting visitors at national events to helping guests navigate government buildings, museums, and tech expo. Sara made her public debut at LEAP 2024, Saudi Arabia's flagship tech conference, where she held real-time conversations with attendees, asked follow-up questions, and responded with facial expressions that matched her speech. Powered by a custom-built LLM fine-tuned for regional dialects and social etiquette, Sara can even recite poetry, tell jokes, and answer questions about Saudi culture. While she doesn't yet walk, her upper body gestures, interactive dialogue system, and emotional awareness make her a surprisingly lifelike assistant. As Saudi Arabia pushes forward with Vision 2030, Sara might just become the first AI ambassador for a new kind of high-tech, high-touch future. After years of jaw-dropping acrobatics from its hydraulic cousin Boston Dynamics, unveiled the all-new Electric Atlas in April 2024, and it's not just a reboot, it's a complete transformation. Sleek, clean, and shockingly quiet, this version is built not for stunt reels, but for real-world work. Standing at 5 feet 9 inches, 1.75 meters, and weighing about 180 pounds, 82 kilograms, Electric Atlas is all electric and fully optimized for industrial use. It's faster, lighter, and far more agile than previous models, and now it's tetherless, meaning no more bulky power cords dragging behind. In the launch demo, Atlas effortlessly picked up and loaded heavy toolboxes, spun 180 degrees mid-stride, and recovered from awkward terrain like it was walking on flat ground. But what really stood out was the precision. The robot could manipulate objects, realign its stance, and respond to sudden changes using onboard cameras and force sensors, all in real time. Atlas is now being integrated into Hyundai's factory pilot programs, moving car parts and staging tools in dynamic assembly lines. Boston Dynamics isn't trying to entertain anymore. This time, they're building a robot that's ready to clock in and outperform a human in raw movement, strength, and stamina. Optimus Gen 3, revealed in early 2025, marks a huge leap from Tesla's earlier humanoid prototypes. This version isn't shuffling across a stage, it's walking with purpose, lifting real weight and executing precise tasks inside actual Tesla gigafactories. Built at 5'8", 1.73 meters, and weighing roughly 150 pounds, 68 kilograms, Gen 3 is Tesla's most refined humanoid yet. With new articulated hands, fully integrated Tesla-designed actuators, and upgraded AI vision trained using the same data stack that powers FSD, this robot isn't guessing its way through tasks, it's learning fast. Tesla showed the robot autonomously sorting battery cells, moving crates, and doing light assembly work, with the kind of hand precision you wouldn't expect from a general-purpose robot. CEO Elon Musk claims it can do more useful things every month, and the company's goal is mass production at costs eventually below $20,000 per unit. While it still can't run or handle dynamic balance challenges like Atlas, Optimus Gen 3 is now fully integrated into Tesla's own manufacturing workflow, a testing ground that no other robotics company can match. It's not a concept anymore, it's a factory worker with its own badge. When Figure AI unveiled Figure 02 in 2024, it marked a serious shift in how humanoid robots were perceived. not as research props or marketing gimmicks, but as practical, scalable labor solutions. At 5 feet 6 inches and about 132 pounds, 60 kilograms, Figure 02 was built from the start to replace human labor in repetitive, dangerous, or physically demanding jobs, starting with logistics. Its form is lean and human proportioned, but under the hood it's all machine. Torque-controlled joints, articulated hands with soft grip sensors, high-speed vision, and real-time feedback across every limb. Early pilot programs at facilities like BMW's factory in South Carolina showed Figure 02 autonomously walking, identifying parts, picking and placing containers, and adjusting actions mid-task, all while communicating with human staff. Originally, Figure 02 ran a multimodal reasoning stack powered by OpenAI, giving it the ability to hold conversations, interpret visual scenes, and follow complex voice commands. But in February 2025, Figure AI publicly ended that collaboration after claiming a major breakthrough in proprietary end-to-end robot AI. Their new system, built entirely in-house, now powers all current units, and early demos suggest it's just as capable, if not more streamlined. Figure 03 is currently in development, aiming to transition from carbon fiber prototypes to mass production-ready hardware, including die-cast joints and molded shells. But until then, Figure 02 remains one of the most advanced, real-world tested humanoids actually operating on factory floors today, quietly redefining what a robot coworker looks like. Meet Apollo, the full-sized humanoid robot from Apptronik, a Texas-based robotics company with roots in NASA's Valkyrie program. First unveiled in August 2023, Apollo has evolved into one of the most promising general-purpose humanoids designed to operate in human environments like warehouses, hospitals, and manufacturing plants. Standing 5 feet 8 inches, 1.73 meters, and weighing about 160 pounds, 72 kilograms, Apollo is built with modularity and safety in mind. It's designed to be human safe. Every joint is force limited, which means it can work alongside people without the risk of knocking someone over. The robot features 2 fully articulated arms, expressive LED face panels, and a core built around hot swappable battery modules that give it about 4 hours of operation per pack. Apollo isn't designed to sprint or do flips. It's made to move packages, push carts, deliver parts, or perform repetitive inspection tasks in real-world workplaces. It walks smoothly, turns confidently, and can carry loads up to 55 pounds. By 2025, Apollo is already being piloted in collaboration with Mercedes-Benz and Jabil, where it's actively deployed on factory floors, handling line-side delivery and material movement. Apptronik's goal is ambitious: create a robot that fits into any human-designed workspace without needing to redesign the world around it. Apollo doesn't try to be flashy, it's just here to get the job done. Agility Robotics DiGit isn't here to entertain, it's here to work. Standing just over 5 feet 9 inches, 1.75 meters, tall, and weighing around 140 pounds, 63 kilograms, DiGit has quietly become one of the most deployed and real-world tested humanoids in the US, with active pilots underway in warehouses and fulfillment centers. Unlike some flashier bots, DiGit's design is all about functional stability. It uses reverse K knee legs for efficient walking and energy conservation, and it's built to operate in human environments, meaning it can climb stairs, open doors, pass through ADA-compliant hallways, and even ride elevators. Its torso features swappable end effectors and handle totes in logistics workflows. DiGit can now self-right after falling, and newer updates have added autonomous charging and improved vision for better item recognition. In collaboration with Amazon, DiGit is currently being tested to perform tote recycling, grabbing empty bins, moving them across facilities, and preparing them for reuse without disrupting human teams. Agility isn't pitching DiGit as a future concept. This robot is already walking factory floors, doing real tasks. It may not look flashy, but in terms of deployment, DiGit is one of the furthest ahead humanoids in the game today. Themis V2, unveiled in early 2025 by Westwood Robotics, is one of the most under-the-radar but technically brilliant humanoids to come out of the US in recent years. While the company avoids flashy demos, Themis V2 is quietly catching the attention of robotics insiders for its precision balance and manipulation. Built at 5 feet 10 inches, 1.78 meters, and 155 pounds, 70 kilograms, it's made from aerospace-grade composites with ultra-quiet actuation and an internal neural control loop trained for tool use, not just movement. What sets Themis apart is its intentionality system. The robot doesn't just move its arm to grab an object. It models the object's purpose, how it's used, and adjusts its grip based on task-specific feedback. In one demo, it picked up a wrench, analyzed bolt alignment, and made torque corrections in real time. It's not a warehouse hauler or a customer greeter. Themis V2 is built for lab work, assembly lines, and machine calibration, where precision beats speed every time. Westwood isn't mass producing it yet, but with a few strategic pilots in aerospace and clean room tech, this may become the go-to robot, where, close enough. Realbotix made headlines years ago for its hyper-realistic androids, but with Aria, launched in 2024, they've gone a step further. Aria isn't just a face, it's a full humanoid platform that blends emotional realism with mobility and AI interaction. Standing 5 feet 5 inches, 1.65 meters tall, Aria features silicone skin, ultra-silent micro actuators for facial expression, and a conversational AI stack that supports natural, flowing dialogue. Her face can smile, blink, frown, squint, and show subtle shifts in emotion, all timed with speech that adapts to tone and pace. But the real evolution here is that Aria now moves. While not built for speed or heavy labor, she can walk short distances, gesture fluidly, and use her hands for simple object interaction. That opens the door to roles in retail, concierge services, therapy settings, and even companionship application. Realbotix has always leaned into the uncanny valley, but Aria feels like a turning point. A robot designed to be emotionally engaging and physically present, without pretending to be something she's not. For people looking for humanoids that connect, not just compute, Aria might be the most convincing one yet. Eliza Wakes Up is less of a robot and more of an experience. Launched by Eliza Studios in 2025, this humanoid doesn't just respond to commands. It tells stories, shares memories, and expresses growth over time. Standing 5 feet 4 inches, 1.63 meters tall, with a soft, matte finish and glassy eyes that react to light, Eliza is designed to blur the line between character and companion. Built on a generative AI stack, Eliza remembers previous conversations, adapts her speech to your tone, and even reflects on past events in ways that feel more like talking to a friend than querying a machine. She doesn't walk much, just a few careful steps, but she sits, gestures, tilts her head, and changes vocal tone to match emotion. The whole platform is focused on emotional presence. In pilot programs, she's being used for therapy, memory care, and creative writing workshops. Eliza doesn't pretend to be human, but she's not pretending to be dumb either. Her creators don't talk about utility, they talk about connection. And in a world where most humanoids aim to work, Eliza Wakes Up is trying something different, making you feel seen. Physical Intelligence, a robotics startup based in San Francisco, isn't building its own humanoid hardware, at least not yet. Instead, they're focused on something arguably more powerful, the brains that can drive any robot body. In 2024, they introduced P0, a foundation model for general-purpose robot control, something like ChatGPT, but for physical actions in the real world. P0 is a vision language action model trained to understand visual scenes, read commands, plan multi-step tasks, and execute them through robotic hardware. In public demos, the model was used to control robots performing a wide variety of tasks, folding laundry, bussing tables, clearing clutter, and even grabbing items from shelves with no prior scripting. The model doesn't just react, it plans. When given the command, clean up the dining table, it identifies objects like plates and cups, figures out which ones go where, and carries out the task across several steps, adjusting as the scene changes. Physical Intelligence's biggest contribution is software that can transfer across different robot bodies, from mobile arms to potential future humanoids. They're not building the next Atlas or Optimus, but the next robot that thinks like one might just be running their code. Unveiled at CES 2025, Melody is the latest humanoid robot from Realbotics, a California-based company best known for its work on hyper-realistic androids. But unlike their earlier creations focused on entertainment and companionship, Melody marks a shift toward broader use cases: education, therapy, hospitality, and interactive retail. Standing approximately 5 feet 5 inches, 1.65 meters tall, Melody is built on a modular, open-source framework, allowing users to customize both hardware and software. Her frame features Dynamixel P-series servo motors, giving her remarkably smooth and lifelike motion, while her face includes advanced eye tracking and visual sensors that enable sustained eye contact and contextual awareness. The standout feature? Portability. Melody can be fully disassembled and packed into a suitcase-sized container, making her easy to ship, store, or transport between locations, ideal for traveling exhibits or distributed pilot programs. Melody runs on a flexible AI backend that supports integration with both Realbotics' proprietary conversational models and third-party platforms like OpenAI's ChatGPT. This makes her a versatile interface for personalized learning, emotional engagement, or customer service roles. By shedding some of the baggage associated with previous Realbotics projects and focusing on openness, realism, and adaptability, Melody represents a new kind of humanoid, one that's expressive, mobile, and ready for work in the real world. Persona AI is a Houston-based startup you'll want to keep an eye on because they're doing something most humanoid companies aren't even trying. Instead of chasing viral dance clips or showroom demos, they're going straight for heavy industry. In 2024, Persona AI signed a multi-company agreement with HD Korea Shipbuilding, HD Hyundai Robotics, and Vasilco to co-develop humanoid robots designed for real shipyard work, specifically welding, inspection, and maintenance in tough industrial environments. Under the deal, Persona AI is in charge of both the robot hardware and the AI brains that make it move, learn, and adapt. These robots won't just follow scripts. They'll use reinforcement learning and visual reasoning to perform precision welding, even in the tight and hazardous spaces of ship hulls and dry docks. The timeline? Prototypes are set to roll out by late 2026, with the first full deployments expected in Korean shipyards by 2027. This project isn't about selling bots to consumers, it's about solving labor shortages, reducing workplace hazards, and showing that humanoid robots can actually take on blue-collar jobs. If all goes to plan, Persona AI might end up building one of the first humanoids that makes its living doing real, dirty, hands-on work. So now you've seen it. Not sketches, not prototypes, real humanoid robots, walking, thinking, working. And they're not coming, they're already here. Factories are getting quieter, airports have robotic greeters, hospitals are testing nurse androids, and somewhere in the desert, a machine just ran a half marathon while another one learned how to weld a ship. But here's the part that should keep you up tonight. This isn't just about tech, this is a race. And right now, it's China versus the United States. On one side, you've got Unitree, XPeng, UBTECH, companies dropping fully functional humanoids like it's no big deal, selling them for a fraction of the cost, deploying them by the hundreds. They're faster, cheaper, and already loading boxes, scanning cars, even patrolling assembly lines. Tesla, bigger. Boston Dynamics, pushing raw power, multimodal reasoning, surgical precision. But they're moving cautiously, slow, expensive, and still catching up in some places where China's already mass deploying. This isn't just a tech war, it's an automation arms race. And whoever wins rewrites the rules of the global workforce. So ask yourself, what happens when the average Chinese factory has more robots than workers, and they're not breaking down or taking breaks? What happens when American robots start replacing not just laborers, but decision makers? And what happens to us when machines can do almost everything better? Is this progress or a countdown? You decide. Because the future isn't arriving someday, it just walked past you, and it didn't blink.